Welcome back, algebra students. We are in for another fun-filled day of order of operations with scientific notation. The last video was over multiplying and dividing. Today we're going to focus on, you guessed it, adding and subtracting. Most of you would probably agree that if you were working with fractions, it's a little easier to multiply fractions than it is to add and subtract, because when you're adding and subtracting, you have to have a common denominator, but with multiplying and dividing, you do not. Well, the same thing kind of is true with scientific notation. In order to add and subtract, instead of having to have a common denominator like in a fraction, you have to have a common exponent, and that's what this tells us. Our I can statement is I can use the order of operations to solve problems expressed in scientific notation. You can see that our focus today is adding and subtracting. The note is when adding and subtracting numbers in scientific notation, first, the exponents must be equal. So that's kind of our important clue to remember, and therefore I gave you a note on that. All right, so we have to put the exponent into the same number. We have to change it to the same number. So just a first thought, let me go back to this first slide, and I just want to tell you that the same thing applies. Last slideshow, last notes, I gave you the example with A, B, C, and D, and the same thing holds true. So let's see, this is what the format, this is how your problems are going to look today. So let's say we have 7 times 6 plus 5 times 6. Now, what you notice is that the 6 is the same number. For our purposes today, as you guessed it, scientific notation, that's going to be times 10 to some number. So if I was going to do this problem, if I just did this problem, it would be 42 plus 30, which we know is 72. Everybody's okay with that. Well, the format we're going to be following today is that idea of A, B, C, and D, where B and D are really the same number, and we add A plus C. So if I were to do A plus C times, and this one's B or D, because you know that's the same number, and then this is what we would get. I would do 7 plus 5, put that in parentheses, and then multiply it by, in this case, 6. 7 plus 5 is 12. 12 times 6 is 72. And as you can see, both of those equal exactly the same thing. So just much like that example, we are going to be working with order of operations today, and the same rule applies. And so we like that because then we don't have to worry about distributing each number to each part of the parentheses. So here's what it's going to look like. It says 3.4 times 10 to the second plus 4.57 times 10 to the third. So we either need to change the first set of parentheses, the numbers in the parentheses, to 10 to the third, or we need to change the second group of numbers both to 10 to the second. And you know that we can do that simply by moving the decimal point. So what I want to do on this first example, I'm going to change both so that both exponents read 10 to the third. We're going to change 3.4 to 0.34 times 10 to the third. Now let's talk about that for just a minute. If the decimal is in this position and I have to multiply by 10 to the second, I know that I would have to move the decimal 2 places to the right. That's what scientific notation tells us. But if I move it back one more place, in other words, if I move it to be in the position in front of the 3, then no longer am I multiplying by 10 to the second. Then I can multiply by 10 to the third, and then we end up with 340 no matter what. So I chose to move the decimal back one place, and now I have times 10 to the third. Now we're kind of in luck. So then that means plus, we just leave 4.57 times 10 to the third. I'm going to leave both of those in our sets of parentheses. And then the rule that I just discussed with the A, B, C, D, now that applies. So what we want to do is add A plus RC, so 0.34. I hope you're writing this down because as I'm taking as I'm talking to you, you're taking notes so that you can refer back to this when it's time to do the work in class tomorrow. So we're going to add those together and then multiply by our common exponent, 10 to the third. When I add those together, I end up with 4.91 times 10 to the third. Then the final question is the answer in scientific notation? Yes, it is, because the first number is in between 1 and 9.99 times 10 to the third power. So we're in luck there. All right, moving on to the next example. Here's our choice. I see 10 to the fifth. I see 10 to the sixth. So I can either change 1 to 6, change the first one to 6, or change the second one to 5. I'm just going to choose to make both of them 10 to the sixth. But as I mentioned earlier, you can do either. It doesn't matter. You should still get the same answer. So if I want to change 1.2 to a number where I'm multiplying by 10 to the sixth, then I would have to move the decimal back one place. That makes it 0.12 times 10 to the sixth plus, keep that in parentheses, of course this is going to stay the same. So the thought process, because I know it kind of just takes a little brain work when I'm moving the decimal point, if I was in this position and I was moving it 5 places to the right, then I would have to move it back one more place to move it 6 places to be in the same position. So as far as what to combine, I'm going to add 0.12 or whatever in the A position. We call that A, B, C, and we could call this D. We know B and D are the same. So if I was going to add, then I would say 0.12 plus 5.35, put that in parentheses, times, now we have both exponents as 10 to the sixth, 0.12 plus 5.35 is equal to 5.47 times 10 to the sixth. Now remember, we have to make sure that's in scientific notation, and 5.47 is in scientific notation, or between 1 and 9.999, repeating. As you're taking notes at this point, I want you to go ahead and just pause the video, and I want you to work number 3 out by yourself, and then once you have completed it, then go ahead and start the video. Welcome back. Let's see what we have here. I see a negative exponent, but that doesn't really matter. It's still going to be the same process. We want to change both to -3, or we're going to change both to -2. It doesn't matter whichever one you choose. I'm going to choose to change both to 10 to the -3rd power. So here's the thought process. Here's my decimal. So if my decimal is between the 6 and the 9, and if I'm multiplying by 10 to the -2, then we know that the rule is to move it back 2 places to the left. Okay, and then we would have 0.0691, as you can see. But if I'm going to multiply by 10 to the third, then that means that I would have to go one additional place. So then my decimal is going to look like 69.1. So that, in other words, I would start in this position. Now if I move it back 3 places, then it will be where I would have landed with the 10 and -2nd power. So we want to move it between the 9 and the 1. Please, instead of trying to memorize a rule, just kind of stop and think of that thought process. I was supposed to move it 2, but now I want to move it 3, so now it has to land between the 9 and the 1. So we have 69.1 times 10 to the now third power. Remember that -3 simply means moving the decimal 3 places to the left. And then I'm just going to rewrite the second part of my equation and put it in parentheses. As far as what to put together then, we look at our leading number within the parentheses, so 69.1 plus 2.4. And all of that times 10 to the -3rd power. 69.1 plus 2.4 gives me 71.5 times 10 to the -3rd. But then it has to be in scientific notation, so now we have to think about this. In order for it to be in scientific notation, it would be 7.15. We know that. So in the original position, the decimal was between the 1 and the 5. So I would have to move it back 1, 2, 3 places, and that would be our final answer. But when I have it between the 7 and the 1, I've already moved it one place. So now I no longer have to move it 3 places. I only have to move it 2 positions. Final answer in scientific notation. The same rules apply when I'm subtracting. So moving on to the next slide, we see 3.67 times 10 to the second minus the quantity 1.6 times 10 to the first. So how are we going to do that? All right. 3.67, the same thing applies. I can change them both to 1, or I can change them both to 2. That's entirely up to you. What I want you to keep in mind, and as you're checking this, is that you can, with your calculator, let's think about this. This is just sort of a side note. So 3.67 times 10 to the second, that would really be 367. And then 1.6 times 10 to the first, if I move the decimal one place to the right, then really that just means 367 times 16. 367 times 16, I'm sorry, minus 16, sorry. Minus 16, I bet you already caught that. 367 minus 16 gives me 351. If I'm writing 351 in scientific notation, then the answer is 3.51. We place a decimal here. This is where it was. That's 2 positions times 10 to the second. So that's the answer that we should be getting. So I'm teaching you this kind of shorthand method. In other words, just kind of concentrating on changing the exponents, and that is the method that you would need to follow. However, just keep in mind what I did also is true. So I'm just going to write that over to the side so we can check at the end, make sure that it matches up. But let's talk about using the same exponent. So I'm going to choose to change both of the exponents to 10 to the second, so that just leaves the first one exactly as we see it. And then the second one, if the decimal is where it is right now, then I would move it one place to the right to get to this position. But if I want to change that to times 10 to the second, then instead of being in this position, it would have to be here, and then I would move it 1, 2, and that gives me 0.16 times 10 to the second. If you're thinking, okay, I understand what she's saying, but I don't know if I could do that on my own, I would suggest just pausing the video for a second and kind of wrapping your head around that. I would move it one place from this position, but I'm changing it to 10 to the second so that my exponents match. That means that I have to move it back one place and then move it forward 2 places, and then I'd be in the same position as where I began. So that's kind of the thought process behind this. So we end up with now 3.67 minus 0.16 minus, and what do we have left? We have, I'm sorry, times, that's our times 10 to the second power. So 3.67 minus 0.16 gives me 3 51/100 times 10 to the second. And is that in scientific notation? It sure is. On the next example, I'm going to change both of them to 5. So I'm just going to leave this one, 1.33 times 10. Oh, and by the way, it did check. Look, we did a great job. Give yourself a pat on the back. Nicely done. 1.33 times 10 to the 5th power. I said I was going to leave it as that. Minus, and then we have 4.9 times 10 to the 4th. I know I'm going to change it times 10 to the 5th. From this position, I would have to move it 4 places. 1, 2, 3, 4. So I'm going to have to move it back 1 in order to move it 5 and still be in the same position. So as far as what we put together, we take our A term and our C term, and we're going to subtract those. 1.33 minus 0.49 times 10 to the 5th power. What do we have here? 84/100 times 10 to the 5th. Doesn't look like that's going to work, does it? So we have to change it into scientific notation. How do I do that? I know the decimal needs to go between the 8 and the 4. In this position, I would move it 5. So now, when it's between the 8 and the 4, I only have to move it 4 places. If it helps you, you can do this. Say 0.84. Okay, I would have to move it 1, 2, 3, 4, 5. Okay, but in order, I want to get to this position. That's my goal. Now, if I move it one place to the right on its own, then now I only have to go 1, 2, 3, 4 places. Hope that helps if you're having difficulty. Go ahead and pause the video and please do the last example on your own. I know you can do it. All right, welcome back. Let's see what we have here. So now we have a negative exponent. Let's see how we handle this. I'm going to change both to -6. So I'm just going to leave the second part of this alone. And then the first part, we need to change it to times 10 to the -6. So here's my thought process. I'm in this position and I have to move it 5 places. But now I want to move it 6. So that would mean 84.1. In other words, I'm going to have to move it back this direction in order to move it 6 places and be in the same place I would have had I moved it 5 from here. Now, if I move it there, then I can multiply by 10 to the 6th. Put this in parentheses. 84.1 minus 7.9 times 10 to the -6 power. 84 minus 7.9 gives me 76.2 times 10 to the -6. The last thing is to make sure that it is, in fact, in scientific notation. I don't believe it is, my friends, so we're going to move it back one place, and then the question remains. 7.62 times 10 to the, in this position, I would have gone left 6 times. 1, 2, 3, 4, 5, 6. But now, in between 7 and 6, I no longer have to move it 6 places. I only have to move it, you guessed it, 5 places. Final answer. That's going to do it for us with scientific notation using adding and subtracting. I hope you learned something new today.